Hey, once again, it's KP the Math G here, and I am delighted to be standing before you to do yet another calculus problem. Whether you are a teacher or a student, either one, at this point in the summer, anybody, I like to think that if there is a first year teacher out there, that they can look at these videos and get an idea what they need to teach these students. And if you are a student, well, you're already, if you are fixing to start this class, you can get a good head start right here. Of course, if you haven't had anything just yet, you'd have a few preliminary things you have to learn about the derivative and the antiderivative and limit and so on. But if you've gotten that far, you're in good shape for this problem here. Let's examine this. This is a 2016 problem, free response problem, question number 5. And I looked through all of the 2016 questions. All of them are really good, by the way. I just happen to like question 5 mainly because I've already done some lessons on those first 3 or 4. Although it wouldn't hurt to do those lessons again by way of remembrance. But this is the one we're looking at this point. It's a funnel, that's what it is. And so it just says the inside of a funnel of height 10 inches. So we know that the total height is 10 inches. So we're starting from 0 to 10. Okay. Has circular cross sections as shown. The radius is given to be by this, and actually, when you think about it, this is not a cone. I tried to do this one time before, and this is just, you try to think, oh, this is not a cone. You have to take this for what it is right here. This represents the equation for this anyway, even though it says radius here. You have your radius and your height represented. So that is your equation that you're looking at, okay? So just kind of keep that in mind. H is between 0 and 10. Alright, so find the average value of the radius. Now remember, average value, what does it look like? Well, I think I have there's my blue marker, I didn't see that. Average value is always going to be, okay, if you're going from 0 to 10, so it's going to be 1 over 10 minus 0. Always remember that when you're dealing with average anything, average value, then you are going to have a 1 over and then 10 minus 0. Had this been a 5, it would have been 10 minus 5, and so on. You're going to integrate, and you're going to integrate from 0 to 10. Alright? Okay, because this isolate interval could go all the way from 0 to 10, anywhere in between there. Okay, so including 0 and 10, but we're just picking one, say right here. And of course, we're looking at the equation. So 1 over 20, 3 plus h squared dh. And that's it. If you're dealing with everything in terms of h, this has to be dh. Okay? Alright, well, we want to find the average value of the radius, and we are going to do that when we integrate this. always remember you're integrating this and then you're dividing by the average height here. So really what we could do here, 10 minus 0 is just 10. So this is just 1/10 here. If you wish, now we could do this by hand, and I'm probably going to flip the board over and do it by hand. But you can also do it on your calculator. Everything here really can be done by hand on this, in this problem here. I mean, everything can be. If you want to do it by calculator, you can go to, some people go to VARS, but actually what you want to do first is put this equation right here. I have a y sub 0. Put, y equals, okay, at the top left hand corner of your calculator. I think it's, most all of them are the same. And then just put this function in there, okay. So 1 over 20 3 plus h squared. Close it up like that. Make sure everything is copied correctly. Yours may have a y sub 1. Might start off with that. But mine has a y sub 0, so I'm going to leave it as y sub 0. Just so you know. Okay. That's what mine has. Okay. And you can put that in there, and you can put that in place of this right here. So really, when you do your 1/10, you could go from 0 to 10, and then you can put y sub 0, and then of course it's going to say dx on the end like that. That is the same thing here. To get that in here though, you've got to, in my case I can go straight to y vars, but for you, you may have to go to vars and then y vars, and then it'll come up with this menu here, y0, y1, y2, etc. And then you pick, in my case, y0, and then you can put that in there. So if you put that in from the very beginning, you don't have to integrate or do anything, unless they say, well, you do not need a calculator for this problem. Then you have to do it by hand. Let's put the problem back up here. Let's flip it over so we can have a little room to work it. I'm going to do it by hand. Alright. Alright, here we go. This is 1/10. 1/10. Alright, I want to say this is 1 over 20. 3 plus h squared dh right there. Double checking to make sure. Now that's it right there. Again, this is always average radius. Okay. We can do this, make it 1 over 200. So, oh yeah, we're going from 0 to 10, by the way. Alright, 200. From 0 to 10. Now we're left with just 3 plus h squared dh. This is actually very easy to integrate. So what we have here is 1 over 200, and again, you should know by now. If you haven't, just remember to tack that h on right there. Now add the exponent and divide by that same exponent, and you're going from 0 to 10 like that. Okay, it's really simple, okay, I think, but it's just the idea of knowing what average value is, and that's really what it is. It's 1 over 10 minus b minus a times this function, and then from 0 to 10, of course. Alright, so we're going to plug in 10 here. So 3 times 10 plus 10 cubed over 3. And of course, if you plug in 0 here and 0 here, you're just going to get 0. You might want to show that on the test. Okay. If you're doing this by hand, you will get, okay, this is 30, so 1 over 200 times 30 plus 1 over 200 times, just add 3 zeros to 3, like that, and you should come up with your answer fairly quickly. I mean, you don't have to do this. You can probably just put this in your calculator and get your answer just the same, okay? Doing it by hand, I just distributed the 1 over 200 on both of these. And of course, your final answer is equal to actually it's 1090 over 600. But then of course you can cross out a 0 at the end, so 109 over 60. Do they want units on this? Let's see, find the average radius. Okay, since this is in inches, yeah, you might want to go ahead and put the units down. It's a radius, so radius is in inches. In this particular case, we're having to deal with inches. Okay, there's the first one right there. That's A part right there. Alright, average. 1 over 10 minus 0, and then integrate this from 0 to 10. And that's really basically it. I mean, okay. Alright, average is always going to look like that. Okay, just kind of keep that in mind. Alright, here we go with the next problem. Let's see what it says here. Letter B. Let's see what we got here, guys and girls, and ladies and gentlemen. Volume of the funnel. So we need to find the volume. Find the volume. I'm just going to leave it like that. Now, if you make a mistake and call this a cone, it is not a cone. The whole thing is given by this. So what we have is a circular cross section. We're looking at pi r squared and then h, delta h, okay, or dh. That's what we have. Now, pi r squared, there's your circle, and then your height, well, delta h is what it is. dh is what you put on the end. So you just got to remember that one there can be confusing. If you mistaken this to be a volume of a cone, you know that the volume of a cone is 1/3 pi r squared h, like that. 1/3. You're going to use that 1/3 in there. No, you don't do that. Just understand by the reading that this is it right here. Okay, R and H are already represented here. So in this particular case, all we're doing is, now the volume, don't put 1/10 in front, that's average. Okay, we're not dealing with average, but we still go from 0 to 10. Okay, and put the pi here if you want to. R squared, we know what R is. That is 1 over 20 times, let's put this like this maybe, times 3 plus h squared, and all of this is squared, and then dh right there. Okay, the I subintegral is the thickness here, right here. Alright, there you go. And let's take a look at this here. We're just going to look at that. Let's see, if we square the 1 over 20, that's 1 over, doing it by hand again, 1 over 400. 20 squared is 400. And then, of course, you have to square this binomial here. So you're squaring that and then dh like that. Again, I can put this pi over 400 right here. Like that. Remember, this is over 1, so you can just do that. You're going from 0 to 10 here. And then 3 times 3 is 9. 3 plus 3 is 6, so 6 h squared plus h to the 4th. Alright, h squared is h to the 4th dh. Now, it's really very simple. And here again, you could have done this, and if you'd gotten to your y bars, let's just say you get to y bars, okay, and you have that option y sub 0 again. Well, what you could do is you could simply, if you want to start off putting that pi in front right there, you can. Alright, and that calculators will put the exact value of pi there. Alright, 0 to 10, and then you could put y sub 0. And I don't know if you need a, I don't think I needed parentheses. I think I could just put the square up here like this. And of course it says dx on there. It's always going to do that. And you can do it that way. You can call it up. That's one reason I put them in there. You know, y equals from the start. I can just pull this up and it'll just shoot out the answer. Okay. Alright, so here we go again. Pi over 400. Now the integrating of this is 9h plus 6h cubed over 3. We know that 6 over 3 is 2, so I'm just going to go ahead and make that a 2. Alright, right there. And now h5, h to the 5th over 5. And then from 0 to 10. Like that. Okay. We know that the 0, everything is h here, so that's going to subtract off. But here we go with this, pi over 400. And I'm just going to get so far with this. So 9 times 10 plus 2 times 10 cubed plus 10 to the 5th over 5. Alright, like that. And then, of course, if you want to, you might want to say minus 0. Okay, for good measure. And then the answer to that one is in lowest terms. Okay. I want to say you get 22,090 over 400, I think. Yeah, 400. Don't forget to put the pi on the end here. And of course the zeros do divide out. So there it is. And then of course we want to put it in cubic inches. We are looking at volume, aren't we? So there it is. So we find the volume. That's how you do it. You go about doing it that way there. Okay. Alright. There it is. Okay, finally, and I think the last one is probably the easiest one. So let's look at that. It's not going to take long to do it. So let's go ahead. Yeah, I mean, just remember about this one. This one was a little confusing. Just be careful that you understand this is not a cone. It is a funnel, and it's represented by this function here. So you just pi r square that. Okay. Cross section is a circle, and of course volume at dh gives you the extra dimension right there. Okay. All right. Oh, nice little problem here. If you put h, if you think, oh, I'm going to multiply by h, that's an extra dimension, especially when you put the dh on the end there. With that, that's an extra, you're adding an extra dimension to that, which be 4-dimensional, not 3. So Just remember the DH represents part of that dimension, so that's the third part of it, okay? Length times width, and then the thickness of the delta H. Okay, alright, so there you go. Alright, part C. What does it say for that one? Okay, let's say that the funnel contains liquid that is draining. It's draining from the bottom. I'm just going to kind of abbreviate this. Draining, for the lack of time, from the bottom. Okay, so water is draining from the bottom. Okay. Kind of like my wife's glass did. Water was draining from my wife's glass of water at a restaurant where we just came back from a few minutes ago. So, you know, water was draining at a pretty good rate too. So we had to get her. Well, it was kind of slow, but anyway, the waitress noticed that it did have a hole in it. All right. Anyway, water from the bottom. Says at the instant. Let's just say the instant. Alright, so there's I see that as a derivative there. The instant when the height of a liquid, let's say the height, and instead of saying of the liquid, yeah, of the liquid, I guess. Liquid, okay. That's a liquid, it didn't say water, okay. Some liquid, okay, whatever that liquid is. H equals 3 inches. Well, the liquid is decreasing. Since it's leaking, it's going to be decreasing at a rate of, well, 1/5 inch per second. I'll just write it that way. Alright, per second. Alright. Let's write it better than that. Okay. At this instant, what is the rate of change? So I'm looking for a rate of change, dH over dt in this case. The rate of change of the height. At this instant, what is the rate of change of height? Now, rate of change of height is going to be dH. We're looking for dH over dt relative to time. Alright, per second. Inches per second is what we're looking for. Now you got to remember, this is decreasing, which is really dr, the radius. That's the radius, by the way. Dr over dt is equal to, be careful, not 1/5, but it is negative 1/10. Alright, so we're going to have to plug that in at the right time. This is what we're looking for. Okay, I'm looking for this. Alright, this is the unknown. Alright, well, what are we setting up? Well, it's going to be R is equal to 1/20. Alright, 3 plus h squared. Like that. Now, That's what we're doing. This radius is changing. Okay. Let's see. It does say that the radius. Yeah, the radius. This is the radius. Actually, it's dr over dt. All right. Okay. At this instant, what is the rate of change of the height? Well, when it says rate of change of the height, I'm looking for dh over dt. So let's do this. Okay. The derivative of r is 1, but now just dr over dt. Don't forget that every time you take when you take the derivative, if you want to do that, you want to put 1 times that, but 1 times that is that. Okay. Well, let's just do it this way. I'm sorry, I apologize. I like to just multiply this 3 over 20. Alright, plus 1 over 20 h squared. Okay. That's what I'm doing there. Okay. Alright. Now let's do this. Get a different color. Hope I don't run out of time here. I hope I don't. We're going to try it. Derivative of r is dr over dt. Alright. Now that derivative of 3 over 20 is 0. Derivative of 1 over 28 squared is 2 over 20. Remember the 2 comes up here. 2 times 1 is 2. H to the 1 power. Alright. dH. Don't forget to tack that on. dH over dt. We don't need the 1 there. Now let's plug the numbers in at this instant. So this is the instant right here. We don't plug the 3 in here. Don't do that. No, don't do that. Do your derivative first. Get that instantaneous, okay, rate here first. Okay, then plug your 3 in here. dr over dt, be very careful that you make this a negative 1/5. Alright, 2 over 20 is 1 over 10. So 1 over 10 times 3. Oops. Times 3 dh over dt. So that's actually 3 times, alright, over 1, that's 3/10. So I can make that 3/10, can't I? I'm running out of board space, so bear with me as I do all this. And then I want to solve for dh over dt, so I'm simply going to multiply by 10 over 3 times 10 over 3. And very quickly I can see 5 goes into 10 2 times. Okay, 5 goes into itself 1. So 2 times negative 1 is negative 2. So dh over dt is equal to negative 2/3. Now remember, we are talking about inches per second. Alright, negative 2/3 inches per second. There it is. And it's got to be negative because your radius is decreasing. Well, your height is also decreasing. Alright, so remember, as you're going further and further down here, this radius is decreasing, and so is your height at a certain rate. That's what that dr over dt and dh over dt is. Keep that in mind. And there we go. That's it. That's what you needed to find right there. Alright, that's it. Well, anyway, KP the Magic. This is a great problem, wasn't it? Really, all 3 of these? Great problem. Okay, I appreciate you very much. If you like to subscribe and you haven't done so, please subscribe. If you want to make a comment, please make a comment. If you want to hit that like button. You know, I never say hit the unlike button, but if you do hit the unlike button, tell me why you didn't like it. Okay, at least give me that much. But I do smile when I get that like button. I like that very much. But see, you don't have to do any of that. Just benefit from this. Again, I'm not looking for my own glory. This is for you. I do this for you. Alright, well there it is. KP the Math G signing off. Ladies and gentlemen, have a great, great day.